Quick, graph y equals the cosine of the quantity of 3 times x by hand, 2 different ways. This is part of the family of functions series. You will need paper and a straight edge, or you can download this PDF and print it. Press pause as needed anytime during this video. Graph y equals the cosine of the quantity of 3x. The first way is with what we call the cosine dance. Recall what the graph of the cosine function looks like and the 5 key points of interest. These key points are affected by the parameters in the equation. In fact, all the points are affected by the parameters in the equation. The only parameter is the 3 times inside the parentheses. So that coefficient of x, k equals 3 inside the parentheses, affects the width of the period inversely. The horizontal dilation factor, you might recall, is 1 over that value of k, which in this case will be 1 over 3 or 1/3. The period of the cosine is normally 2 pi. For this function, the period is going to be 1/3 times that 2 pi, which is 2 pi over 3. Pause is needed. So the period is 2 pi over 3. We need to use a different scale along the x-axis. We suggest marking off every pi over 3. And recall that pi over 3 is about 1, so whatever you use for the distance for pi over 3 should also be your distance for 1 to keep your graphs proportional. Or you can mark off every pi over 6. That might be a little bit better to do. Pause is needed. So again, the period is 2 pi over 3. The initial point is normally at 0, 1. That point is unaffected by the 3 here, so we will still start at 0, 1. The end of the period is normally at 2 pi comma 1. It's 2 pi away, a period. But this time it's going to be at 2 pi over 3, 1, because the period is 2 pi over 3. Halfway between the two maxes is a minimum. And normally it's at pi negative 1, but we got to go halfway between here, these 2 points, and that's going to be pi over 3 negative 1. The y coordinates are the same, the x coordinates are the ones that are changed. Halfway between the max and min is a point of inflection here and a point of inflection here. So look where halfway in between those would be. And those would be at pi over 6, 0. And at 3 pi over 6, 0, which is also pi over 2, 0. Pause is needed. We'll connect the points as a cosine wave, half of a frown, a whole smile, half of a frown. This is one period of the cosine wave. We want to duplicate the wave in the negative direction. So we're going to go back a period from this initial point, which is normally 2 pi, but in this case it's 2 pi over 3, which is 1, 2, 3, 4, 6 pi. From this one we'll also go back 2 pi over 3, 1, 2, 3, 4, 6 pi. Back 2 pi over 3 from this point, and back 4 pi over 6 from this point. Connect the points as a cosine wave. Concave down, concave up, concave down. Compare this to the parent function. This is the y equals cosine of 3x extended. It keeps waving along. And this is our cosine function in blue. They are going up and down, but very different. So this is one period of the cosine. Remember, any part that goes from the beginning to the end of a period. So that's 2 pi right there. And here's one period of our y equals cosine of 3x. That's one period. This is another period. And this is a third period. and it takes 3 of these periods to do 1 period of the cosine of x. And that 3 is all related to that coefficient of x there. Pause is needed. Generalization, the period of a cosine wave is 2 pi. Maximum to maximum here is 2 pi. But what about the period of an equation of the form y equals the cosine of the quantity some constant times x? And we're using the variable k here. Since k affects the period inversely, the normal period is multiplied by the reciprocal of k. That is, the period of y equals cosine of the quantity k times x is going to be 1 over k times 2 pi, which we would write as 2 pi divided by k. Now this is a big deal. In fact, you should write it down and remember it. Pause is needed. So let's go ahead and see, let's have you try these. State the period of each of the following. There's 3 here. So pause to do these, resume when you're ready. So if the y equals cosine of the quantity 4x, the period is 2 pi over k, 2 pi over 4 in this case, which simplifies to pi over 2. So this would go through its whole wave in a length of or width of pi over 2. The second one, 2 pi over 5, and that can't be simplified. And in the third one, 2 pi divided by 1/3 is really 2 pi times 3 over 1, which is 6 pi. So this one stretches out quite a bit. Pause is needed. Graph y equals a cosine of the quantity of 3x a second way using a table. So we'll start with the table, and these are our values along the axes. Complete the table. Pause is needed. You should just know these. We need to create a second table, and we're going to use the fact that the coefficient of x3 inside the parentheses affects the width or period of the graph inversely. So we need to multiply each x value by 1/3. We're also going to need to change the units along the horizontal axis because of that 1/3. So we're going to mark off every pi over 3 or every pi over 6. Pause is needed. Resume when you're ready. So we went with every pi over 6. So multiplying each x value by 1/3, 0 times 1/3 is going to be 0. The y coordinates are not affected. There are no parameters here that affect the y coordinates, so that'll stay at 1. So 0, 1 is our initial point. Pi over 2 times 1/3 will be pi over 6, comma 0. So we'll plot that one. Pi times 1/3 is pi over 3, comma -1 in this case. 3 pi over 2 times 1/3 will leave you with pi over 2, comma 0. And 2 pi times 1/3 is 2 pi over 3, comma 1. Back to a maximum. Pause is needed. We'll connect the points as a cosine wave. Concave down, concave up, concave down. This is one period of the wave. We need to plot another one, this time to the left. So we're going to go back the period, which is 2 pi over 3, or 1, 2, 3, 4, 6 pi from here. Back 4, 6 pi from here. Back 4, 6 pi from here, which is the period. And back 1, 2, 3, 4, 6 pi from there. Connect the points as another cosine wave. frown, smile, frown. This is our graph, keep waving along here. And we compare it to the cosine parent function. Now you try one. Graph y equals cosine of the quantity of 2 times x. Use either method or both for the practice. Also, what is the period? Pause is needed. Resume when you're ready. And here's our answer in green here. Notice the period is 1 pi. 2 pi over 2 is 1 pi. We marked off every pi over 4. We figured that would be easier to do. Pause is needed. Resume when you're ready.